Make sure the volume's off. Dun, 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 dun. Okay, cool. All right. Okay, so as I mentioned, our job for the next little while, hopefully through this week, is to at least get through learning. And then when you return on that next Monday, Wednesday after fall break, we'll get through the memory system. But the question is a lot of times we kind of use the term learning and memory intertwined with each other. We assume once you know something, once you remember something, you've learned something. But I want to, just for the sake of academic argument or academic conversation, I want to use what we call a construct definition for each one of these so that we can talk about them in their separate little kind of domains of what how psychologists think about what is learning versus what is memory. Okay. And we will start with this little block up here. Okay. When we speak about learning, we're talking about changes in behavior. So we're talking about based on an experience you have, does that increase the behaviors you responded to based on that experience? Or did your behaviors decrease based on that experience? And this is what is known as stimulus response psychology, is when we introduce a stimulus, what is the response of the organism? What is the behavior? Okay. When we talk about memory, we talk about um, uh, knowledge acquisition. It's more like what you're doing in the classroom when you're studying, reading a book, and it's your accumulated knowledge and your accumulated understanding of your experiences. Okay. Now, this is why we need to separate learning, changes in behavior, memory, acquisition of knowledge and experience. Okay. Is that knowledge does not always equate into changes in behavior. All right. What do I mean by that? Let me just give a few examples. All right. Maybe one of the good examples for myself is one of the early research engagements I got into was understanding the difference between healthy and unhealthy intimate relationships. What makes people be in love for long periods of time and have long lasting relationships? I was interested in this because my first kind of career coming out of my bachelor's degree was working in the field of domestic violence and sexual assault, where I worked with a lot of domestic violence survivors. And I wanted to understand, well, if that's the dark side of intimate relationships, what makes a relationship good? And I studied intimate relationships for over 10 years. I did some research projects of my own, um, and all kinds of things. But okay, this is the acquisition of knowledge. Okay. Even though I know all of this stuff about having healthy, intimate, loving relationships, it doesn't mean I still don't make the same behavioral mistakes that everyone else does. I get grumpy. I say the wrong things. I do some right things as well, right? But it doesn't mean that just because I have all this knowledge of intimate relationships that I don't make the same behavioral mistakes that everyone else does. Okay. Now, I will tell you the curse of knowledge is when you do make those mistakes, you have to kind of own up to it because you come to the realization that, oh, Yeah, that was my bad. Okay, so I will say knowledge does have a place in assessing your behavior, but it doesn't necessarily equate to behavior change. Okay. And this is the same thing with, even in college, if you think about how, if you took a philosophy class and think about how much your behavior has actually changed because of that philosophy class or because of that chemistry class or any of those things. That knowledge is important. It provides you with an understanding of the world, but it doesn't necessarily equate to personal behavioral change. Okay. And that's an important point to make. And we could go into, if you're going into like counseling and therapy and all those kinds of things, when I worked in the prison system, um, and we did programming for addiction. We gave all of the tools necessary, all the knowledge of how to be sober, how to prevent relapse prevention, how to all do all of those things. But despite providing that knowledge, the recidivism rates were just as high for the individuals who went through the programming and the therapies and the groups as were the individuals who didn't. So again, it's just this recognition that knowledge does not always change behavior. It can change our understandings of the behaviors we create. Okay. So something to kind of think about and why psychologists separate the difference between learning, behavior, memory, and knowledge. Okay. So the first thing that we need to tackle is understanding this learning and learning process, which if you remember at the beginning of the semester, we talked about the major camps of psychology, and we brought up the camp of behaviorism that was largely here in the United States. It was championed by John B. Watson and B.F. Skinner, who wrote the Behaviorist Manifesto that wanted to make psychology more like the natural sciences. And they argued, what do the natural sciences do? They observe something that they can observe, that the only things that we can observe and are things that can be observed. And what can we observe? We can observe stimuluses in the environment and responses in the organism. So using my little Stewie picture right here, what we can do as good scientists, as behaviorists, is we can observe this and we could observe this and anything in between, mental processes, emotions, feelings, thoughts, consciousness are irrelevant. Okay. So for about 40, 50 years here in the United States, the mental processes were kind of ignored. Okay. We will see how they came back through the series of this lecture, but that was largely ignored. In fact, B.F. Skinner famously said that your consciousness, your memories, and everything are just byproducts of stimulus response associations. Okay, meaning it's meaningless. Okay, what you think and feel and the like. Okay, all right. So that's what we have. So and what did these behaviorists assert is that psychology should only observe what's observable. And probably the important part is that you can observe animal behavior and translate that to human behavior. And this is where I kind of want to step back. None of these individuals that we're talking about, or their predecessors, or anyone else, discovered learning. They didn't discover when you reward something, something happens. When you punish something, something happens. They didn't do anything when you're about how you associatively learn why you get hungry in the kitchen but sleepy in the bedroom. Okay. We've been doing that. We've been training our boyfriends and girlfriends for thousands of years. We've been domesticating animals, our dogs, our cats, well, sometimes cats, for centuries. Okay. the thing that I want to point out is these individuals only investigated these things and gave them definition and understanding. So please excuse me when I say things like Pavlov discovered classical conditioning. He didn't discover it, he investigated it. Or B.F. Skinner discovered what happens when you reward or punish something. Please forgive me if I use that language. Um, and whatnot. But this is an important point because we have been domesticating and training animals for thousands and thousands of years without taking into consideration their emotions, feelings, thoughts, and consciousness. By studying animal behavior, we don't have to worry about that. We don't have to worry about their feelings and emotions as we're training them to do something. Okay. And the person who's going to make this first argument is Edward Thorndike. Now, if you're really interested in animals and animal behaviors and how that translates to human behaviors, he wrote a very short book called Animal Intelligence. It's a very interesting little read about how, and he sets up this argument that goes much deeper than what we're presenting here about how we can observe what animals do and directly translate that into human behavior. Okay. And the interesting thing is, he made this argument based on studying cats, which I find is an interesting species to train and observe. Maybe that's why he made the translations between humans and animals, is because cats are kind of, they do their own thing when they want to do their own thing. So I don't know. I've never figured out why you use cats. Maybe it's because they do assert some type of independence. So it didn't have to worry about anything else. But what Thorndike is going to show is how we can learn and translate problem solving. Okay, and he's going to use a cat in what he called a cat box. And as you note, this cat box, there's this little thing. If the kitty pushes down on here, it's going to open this door. Okay. And in these experiments, what Thorndike did is, sadly, and this is part of behaviorism that I don't really like, but it's necessary, I guess, is they usually starve the little kitty for 1 or 2 days. And then they put the kitty in this cat box, and then they set the food for the little kitty just outside the door where the kitty can see it, but he can't reach it. Okay. And what the kitty has to do is figure out how to open this door. And of course, in this situation, he has to push down on this, which would leave this lever, and the door would open. Okay. And you do that for successive trials. Okay. Now you can see this measured in time. How much time does it take the little kitty to figure out what it needs to do? Is over successive trials that what the kitty needs to do to open the box decreases. Now, what's significant about this, okay, is even though the kitty box looked the same, it had where you put the kitty in and it had this door with the latch, how the kitty opened the door on successive trials differed. So let's say for these first 5 trials, he had to push down on this little card, which would open it. And then on 5 through 10, maybe he had to push a button on the wall. And then 10 through 15, maybe he needed to swat a thing or something. The point being is, even though the mechanism to escape may change, the kitty learns how to figure that out quicker and quicker and quicker over successive trials, because the box itself has remained the same. The lever has remained the same. It's just how the door opens differs slightly. And it takes us less and less time to solve that problem over time. This is kind of the notion of expertise, if we want to think about it in human terms. The more and more we're exposed to a content area, even if a problem is presented to us differently, the expert can more quickly solve the problem. Okay. So it's kind of a learning curve of kitty expertise, if you want to put it that way. But what Thorndike did is he translated these behaviors and said, look, we can replicate this with humans and how humans can quickly solve a problem, even if the problem becomes a little bit more novel over time. Okay. And so Thorndike really sets up the idea of we can use animals to um, do behavior. Now, I'm going to tell you this gets more and more complex as researchers researched more and more complex ideas. So, for example, I studied under a behaviorist for a few years in my undergraduate, and I remember there was a catalog on our desk or on a bench. And in this catalog, you could order mice that were genetically changed. So you could order a mouse that was blind, for example, a mouse that only had three legs, a mouse with Parkinson's disease, a mouse with diabetes, a mouse with part of its left lobe gone, and you literally could order any animal, any type of little mouse, depended upon what you wanted to study as far as functioning based on the condition of the mouse that you ordered. Okay, this is how serious these people got about studying animals and trying to translate it into human behavior. I think they probably have an online thing now. I don't know. But this is also kind of bringing up the issues of, laboratory animals. Is this ethical? Those types of things. So there's a lot of ethics that have to be thought about when doing these kinds of things as well. All right. So the next person that we should talk about, because this also gets into memory systems, but it's also going to talk about learning a little bit, okay? And that's Ebbinghaus test, which he created what is called the forgetting curve, okay? What Ebbinghaus did is he had individuals memorize a list of nonsense words. These words had no meaning. They were just in any language that he knew of at the time. Anyways, excuse me, had nonsense syllables, all of those things. So the point being is the person who was learning these words did not have any previous experience with them. Okay. And so what he learned though is that depended upon elapsed time in days, we get this what's called the forgetting curve. So if you learn them on the first day, of course, you get 100% on them. But then what he asks is don't do anything to try and remember them. Just kind of keep them in mind. Okay. So he's not saying go home and practice them. He's not saying, he's just saying each day what I want you to do is write down the number of words you remember. Okay. We find that at 20 minutes, we remember about 60%. At 1 hour, about 50%. One day, we're about down to 40. And then by day seven, well, around day six, five, six, and seven, we remember about less than 10% of that new information that we've never heard about before. Okay. And this established what is called the forgetting curve. When we get to memory, we'll come back to this forgetting curve because there's nuances to it about how can we enhance learning new information, what can be done to break this forgetting curve, those kinds of things. But as far as learning is concerned, what this taught the behaviorists is that when you're trying to train a new behavior, it really needs to be a behavior that the species is unfamiliar with. So in classical conditioning, we're going to see the associative learning tasks where the animal has to learn that something that has nothing to do with that behavior takes on meaning with that behavior, which I'll get to in a minute. When we get to reward and punishment, to really train that behavior, It has to be a behavior that is novel to that pigeon, to that mouse. When we talk about John B. Watson, remember we talked about little Albert. So little Albert was that he used an infant because he didn't want someone to have experience with little white rats, if you remember. And this is really what the behaviorists took from Ebbinghouse's test. So we have this idea, one, that animal behavior can translate into human behavior, and that when we're training a behavior, the response we should be looking at in the lab should be a novel behavior. It should be something that the species shouldn't normally do in order to, for example, obtain food or to complete some task that the experimenter wants it to complete. Okay. All right. And then the last person we need to look at before we really get into behaviorism is Ivan Pavlov. And this Wednesday, we will go over his ideas of classical conditioning in much, much, much more detail. But he is the one that really set the evidence for conditioning animals and conditioning um, um, species. And it's what really John B. Watson used as the examples to say we should only be studying stimuluses, which in this case is going to be dog food and what happens when you ring a bell with it. And does the animal have the same response to a bell when the food is taken away? Okay. Now, I will talk a little bit about Pavlov really quick. I really think this guy kind of got an interesting history because before, just to kind of set up about what we're going to talk about this coming Wednesday with classical conditioning, is Ivan Pavlov was a physiologist. He actually is not a psychologist, a psychiatrist, a behavioral scientist. He was studying the digestive system. Okay. And it's interesting that we find him in so many psychology books when maybe we should be crediting him for things like antacids and understanding the effects of certain foods, taste, and how taste works, because he was one of the original scientists who figured those kinds of things out. But we know him in psychology for classical conditioning, and I'll give you the basics ideas behind it right here, because what he found by studying the salivation response of dogs is that for some reason, even when the presence of food stimulus wasn't around, if there were certain sounds in the room, such as someone walking across the floor, the dog would start to salivate. And he was interested in why a dog would salivate if there was no food present. Okay. And this is where he started to develop the idea of classical conditioning or associative learning. So, for example, when you see the golden arches, if you like McDonald's, you probably get a few hunger pains. When you see your bed in your bedroom, you might get a little sleepy. And when you go to school, you might get a little anxious sometimes, or the dentist or the doctor. And these are the things that Pavlov was trying to understand and learn. Okay. And so he really kind of set up this idea that we can, again, study things in a systematic way, which we'll get to this Wednesday, and measure it and show how it works. Okay. And then, of course, we'll talk a little bit more about John B. Watson as we did at the beginning of the semester. If you remember little Albert and the pairing of things. And I will say really quick, one thing they didn't do with little Albert is countered conditioning through what's called exposure therapy or exposure. Is that we find, and we'll learn this on Wednesday, that if they only would have presented little Albert with the white rat over and over and over, eventually little Albert would have no longer gotten scared to the white rat because it wasn't being paired with the symbols anymore, the loud banging. Okay. And this is called satiation. Okay. And what we know is that when you pair a nonsense stimulus over and over without its response, it will go away. All right. So, and this is how most, and currently the best treatment for things like phobia and anxiety, believe it or not, are exposures therapies, exposing the person to those anxiety provoking situations. And in fact, one of the leading treatments for combat post-traumatic stress disorder is exposure to the memories and the pictures and the videos of the war zone that the person came from. And that is why in some popular research, and it's showing that that's why in for a lot of military veterans who have PTSD playing online war games, those first shooter games like Battlefield or um, Call of Duty, is actually showing to be very therapeutic for these individuals and actually is reducing their post-traumatic stress symptoms and making them more adaptive to their well-being because of this exposure that we're seeing. So we'll get more of that when we get to the abnormal section. But there was some things that came out of this poor little guy's research and that we'll see that has become very beneficial. And then if you remember B.F. Skinner, he is the guy that we will talk about when we talk about what's called operant conditioning. Operant conditioning is when you have to behave because of a stimulus to learn something. So, for example, a kiddo cleans his room, mom gives him a piece of candy. That candy is rewarding, which theoretically should increase the probability that the kiddo will clean his room in the future. Now, most of you moms in the room are going, yeah, yeah, but a lot of that is nonsense. But we'll get to why it works and why it doesn't work on Wednesday. We'll see that we quite don't do it quite right like we do with pigeons and rats. We'll have to talk about the ethics of doing it correctly to make it work on Wednesday. But we will see that it's not that simple with human beings. But anyways, so this is going to be operant conditioning, where we'll talk about different types of reinforcements, different types of punishments, how they work, and how they operate. Okay. Remember B.F. Skinner, just as a reminder, this is how much he believed in behaviorism, as he said, give me your child, I'll make them into a lawyer, a garbage man, whatever you want him to be, by using operant conditioning. And he set himself up with a pigeon box for children. And remember, he actually wanted to put children in these and train them. Um, and They were just by like 3x5 boxes. And they were meant to keep him in there like he did with his pigeons. Fortunately, the legal system got involved and said no, which so it was never used. But anyways, I just want to remind everyone. Plus, remember that B.F. Skinner created our first precision bomb using a pigeon who pecked at the target and aimed the bomb at the target. But as you recall, just as a reminder, these were never used in combat because for some reason the world had ethical issues about blowing up a pigeon that had no problems blowing up thousands of people. So again, I have a moral conundrum with that, but that I guess the bird won on that end. So once we get through those type of things, we're going to start to reintroduce the mind because we're not pigeons, we're not rats, we're not mice. They have their own unique way of behaving and thinking, and so do we. There are some things that translate, but starting with Albert Bandura, we're going to learn about what's called social learning. Now, you'll notice that I didn't use the word imitative learning. Okay. because I want to differentiate between the two. But let's start with Albert Bandura and what he did with his famous Bobo doll experiment. Okay. If some of you are too young to know what a Bobo doll is, it's one of these kind of balloon plastic things that you blow up. It has a weight on the bottom, so when you push the Bobo doll down, it comes right back up. Um, and what the Bandura did in these experiments was he had a teacher, for one set of kids, he had a teacher who just set up the Bobo doll normally, but then for another set of children, she was very violent with it, hit it with a stick, threw it, all kinds of stuff. And then they observed the kids the next day interact with the Bobo doll. Okay. And what's promoted in the social world, and this is why I don't like students using things like simplepsychology.com or Psychology Today or any of those nonsense websites, is what's promoted is in the media today is that the kiddos who observed the aggressive teacher acted aggressive the next day. The kiddos who saw the good teacher were not as aggressive with a Bobo doll the next day. And this was taken as evidence that aggression is learned. Okay. The reason why I'm putting this caution out there is that the experiment was much, much more complex and there's a whole storyline that is missing, but we will talk about this when we get to the social learning section. And so what I would encourage you today for today is there's not a simple one-to-one, a child observes aggression and then becomes aggression. It's much, much more complex, and we'll review the story on Wednesday. But what Albert Bandura did do is he established this idea of social learning. Okay. And he differentiated this from imitative learning. And over time, since Bandura, we have learned that there's actually only a few species who social learn. Us, dolphins, primates, elephants, and I think there's one other species that does social learning. Okay. All the other species that we've observed and studied do what's called imitative learning. Okay. Meaning they're born to genetically programmed to imitate their mother or their father to understand how to get their food, where the best watering place is, how to build a shelter, all of those kinds of things. They're programmed to one certain thing and whatnot, and they go about with that programming. Humans, dolphins, elephants, other primates, we're a little bit different. We can observe several different behaviors and then develop our own. Okay. So, for example, I can watch my grandma paint a flower, my mom paint a flower, my sister paint a flower, and my dad paint a flower. But then instead of creating their flowers, I then can paint my own, which can be totally different from theirs. I might use the same kind of shapes and what, but it may be a different color. It may be, I might use mom's shape, but grandma's color and dad's stem. I might put a tree by it. I might create something different through all of these observations I've made. Okay. So I'm not stuck with just a basic genetic programming that when I see mom do this, I repeat that behavior to survive. Okay. And this has been the argument of why human beings, for plus several other reasons, have become so adaptive. Okay. Unlike a lot of species who are what called environmentally contained because they can only exist within one certain environment because that's what they're genetically programmed for, quote unquote, or evolutionarily fit for. Because humans have this ability to do social learning, we can change our behaviors based on observations and watching others. and seeing how other people do things. And then we can adapt our behavior the same. I kind of liken this to when I moved from up north to here in Arizona and why I enjoy Arizona so much. Up in Idaho and Montana, you have to plan to do everything because of the weather, especially during the winter. So just simply going down to Circle K requires you to start a car, make sure you have a coat, make sure you're dressed, make sure you have your boots on, make sure you have all of these things in place to go from just point A to point B. Even going to work takes planning. Okay, which creates a very strict culture up there, meaning you have to plan everything. So that means you start a meeting on time, you end a meeting on time. I had the teachers who locked the door if you were late, all of those kinds of things. I moved to Arizona where planning isn't that restrictive. I could after I'm done with this class, I don't have to plan to go to Circle K. I could throw on my shoes, jump in my car, and there I go. There isn't that much planning, so time is much more expansive. It's much more adaptive. And so meetings, start sometime around 1 o'clock. Okay. My point being is that we become adaptive based on the environment, but we're able to because of the flexibility of being able to observe others and adapt to the behaviors that we see that are successful in that situation and in that environment. Okay. And this is going to be important because this makes requires us to think about our behaviors, to mentalize them, to understand them, which is going to bring mental processes back into play. And we will see this really take off with Edward Tolman, who showed that we have actual cognitive maps. And this is kind of funny research because Edward Tolman, uh, let me just put it, he was really famous in his time. Um, he wrote some really very interesting books and everything else, and he worked for an Ivy League university. Um, and I want you to imagine on your first day, you're going to this Ivy League, and maybe you're doing the tour. And on this tour, you go by this world-renowned psychologist's lab, and you look in the window of the door. And here is either Dr. Tolman or his graduate assistant with a little red wagon with a little mouse in it, and they're pulling the little mouse around their lab just in the wagon, and the little mouse is just sitting in the wagon, just riding that little wagon around the lab. You probably think, I'm not sure if this is very Ivy League or not. But what Tolman was actually showing is that you don't actually, as Skinner argued, have to be rewarded and punished for every behavior to solve a problem. That indeed, by experience, you can solve problems. Because what Tolman was showing is that the mouse didn't need to learn to go around the maze to get his food by walking and interacting with walls. No, the mouse was learning how to do the maze simply by a wagon ride. And he found by taking the little mouse with the wagon a couple times that the mouse learned how to get to the food quicker. And he would even change things up by this little device here. Sometimes he would release the mouse in this middle box right here. But then when the mouse was supposed to return, he might put it over here. Okay. If he was only operantly conditioned, he would get stuck right here because this would be the only behavior that the little guy would know. But because he was taken around all of this stuff by not behaving in any way, the little mouse just went ahead and, well, this didn't work, so he went and explored maybe this one. Maybe he went back over here, but eventually he would suddenly just go through here and go, oh, I solved the problem. Okay. And this introduced the idea of cognitive maps, which I think at the beginning of the semester I mentioned. We've learned since the time of Tolman that we actually do have special cells for place, meaning you have a neuron for where you're sitting right now. I want you to think about how cool that is. Okay, you have a neuron for where you're sitting, whether you're sitting in your bedroom, and you have a neuron for each room in your house. And then you have a neuron for your house. Then you have probably several neurons for your neighborhood and for your workplace. And they're specialized cells that kind of create this map in your head about where things are located in space. Now, I think that's cool, but I also know it gets frustrating when those neurons aren't working very well. So, but anyways, this is kind of the evolution of what Tolman found. Is we actually found there is a neural base for what he was experimenting back then. Okay. All right. So where are we headed, and where are we going? So this coming Wednesday, now that we kind of know the history of the studies, we're going to go more into depth, and we're going to start with classical and operant conditioning. So this is associative learning. This is reward and punishment. And then we're going to go into more detail about the social learning, and we'll go into more details about the Bobo doll studies and more things that Bandura talked about, such as self-efficacy, which is your basic belief that you can do something, accomplish something. Okay. And then we'll end with 3 general rules that go across all 3 types of these learning. The first one is generalization. Okay. This is, if you remember little Albert, he became scared of little white rats, and then he became scared of everything that was white and fluffy. Okay. I will bring this up I was talking in my group techniques class. I think a few of you are in that group techniques class on Saturday, and I was talking about my experience working with domestic violence survivors. And in that domestic violence survivors, the majority of individuals that I worked with were women. In fact, I would say 98 and 99% of the survivors I worked with were women. And so, based on those stories, I came up with a huge generalization about men. And so, as I use this as an example of biases, but I had a really hard time working with male survivors of domestic violence because of my generalization that all men, even though I am one, if they are in an abusive relationship, they must be the abuser. Okay. That was my learned process. And we know that, if you think about all men are the same, all women are the same. Um, Anyone who drives a white vehicle is this, or anyone that drives a Chevy or a Ford. So I think we probably understand this rule of generalization. Okay. But there's also the case of discrimination. And this isn't being biased. This is when you can take 2 similar stimuli that are very close together, and you can notice the difference between them. And I'll bring this up again. I'm a social psychologist, and so I'll bring up this idea in the area of social psychology. Okay. Many, I'm not going to say many, but there is a good population of white Europeans here in the United States that hold huge biases and prejudice towards Black Americans. Okay. Um, a lot of these can be unconscious. Some of them are very conscious. Okay. But they might really like the Seahawks, a football team, or the I'm thinking of my favorite basketball team, LA Lakers. And on all these teams, they have a good number of black athletes. Okay. And what do we do on the social end? We separate those individuals and think of them differently than the general population that we've generalized as being black males. And we'll put them in a little discrimination category. But what you will notice is once they stop being athletes, they're absorbed back into the general population of that person's perceptions of black males. Okay, so this is on a social psychology, and this is the notion of discrimination, where you have two stimuli that are very similar, but then you make differences based upon small, subtle differences. Okay. And then we'll talk about the idea of spontaneous recovery, which I will just leave for Wednesday because I have a kind of a funny analogy with this one and exes and ex-wives and ex-husbands and ex-girlfriends and ex-boyfriends and even ex-friends. So we'll talk about spontaneous recovery this coming Wednesday because I want to leave that analogy for that point in time. Okay. So I provided the introduction to what we're going to be talking about, and again, we're going to get into the technical ends of this coming Wednesday. But I do want to stop